So as we have discussed in earlier topic how cell injury was performed by ischemia hypoxia by generating free radicals. Now we will see types of cell injury. I will see types of cell injury. So as I said, cell injury, it can be of two types. So when lethal stimuli is given to a cell, free radicals are produced, and if the stimuli is transient, right? So if stimuli is given for transient period, right? So this injurious stimuli is given for transient period, or if that stimuli is persistent or continuous. So these are two situations we are anticipating, when it is transient, when it is persistent. So transient stimulation, injurious stimuli will induce reversible injury. So this will induce reversible injury, right? So there will be reversible injury because of transient lethal stimuli, and when that lethal stimuli is persistent, that will undergo irreversible injury. That will be undergoing irreversible injury, right? So irreversible injury will start when there is a persistent lethal stimuli, right? So what happens in reversible injury? What are the sequences we will see in irreversible injury? Now we are going to discuss in a sequence. First, from the reversible injury. So first we will see about reversible injury. Reversible injury, right? As I have told you, most common cause of any cell injury is ischemia or hypoxia. So because of ischemia, and we know that because of ischemia there is a hypoxia. So because of ischemia and hypoxia, free radicals are produced and they will cause damage in mitochondria, and this will decrease oxidative phosphorylation. Oxidative phosphorylation will be decreased, right? So because of ischemia, hypoxia, there will be decreased oxidative phosphorylation within mitochondria. Mind my word, what I am saying, within mitochondria. Decreased oxidative phosphorylation due to the ischemia or hypoxia. So when there is a decreased oxidative phosphorylation, what will happen? Because of decreased oxidative phosphorylation, production of ATP will be reduced. So there will be decreased ATP production. Now the question comes to us, okay, we all know that ATP production is gone down in any kind of cellular injury, but what is the limit? What is the limit of, or you can say what is the threshold limit of cell injury for the ATP level, right? So whenever ATP is reduced to 5 to 10% of normal level, 5 to 10% of normal level, it will cause cell injury. So always remember, cell injury will start when ATP will be reduced to 5 to 10% of the normal. So remember this point, this is very important biochemically also, and it can be a future All India question also, right? So this can be a future question also. Okay, when cell injury will start, what should be the ATP level of the normal level? So ATP should be less than 5 to 10% of normal. It should be reduced to 5 to 10% of normal level of ATP in a cell, and that will start cell injury. But question comes to our mind, how ATP is related to cell injury? Means how they will contribute, why they are important, and how they are going to perform cell injury because of the ATP. What is the reason? So when you will see the molecular level of the cell, you will understand any cell. See what I'm going to show you here, a cell, right? And I'm going to show you a cell into two compartments. So I'm just dividing them into two. This side I will show you normal cell, and this side I will show you reversible injury, or you can say injury, right? So normally, what is the role of ATP? Normally when you will see a cell, we'll see that ATP is regulating a membrane, plasma membrane pump which is called as sodium potassium pump, which is called as sodium potassium channel. So in this normal condition, what happens? Sodium will come outside and potassium will move inside the cell. So now remember this normal physiology of a cell. Because of the ATP, remember, because of this ATP, sodium is coming outside, potassium is going inside. Normal cell. So it is controlled by ATP. But when ATP is reduced in reversible injury to 5 to 10% of the normal level, this sodium potassium pump will fail. Because of the failure of the sodium potassium pump, now reverse action will start. Mean to say that sodium will come inside the cell and potassium will be moving outside the cell. Sodium influx, potassium efflux, and that was question in PGI and All India exam. Reversible injury, what happens to the potassium? Potassium goes outside the cell. Sodium comes inside the cell, and when sodium enters inside the cell, what happens? Sodium will bring water along with them. So remember, sodium will bring water along with them. So when sodium and water both will be entering inside the cell, now you can assume that what will happen to the resultant cell? Because of the water, they will be having swelling, right? So because of the water, there will be swelling of the cell, right? So now we can see sodium, water, they are entering inside the cell, and because of this, cell swelling will happen. And this is the first sign of cell injury. Remember, this is the first sign of cell injury. So here we have to understand cell swelling. Cell swelling is the first sign of cell injury, right? So cell swelling is the first sign of cell injury. That is an old important MCQ, right? So this is the one of the important MCQ in exam. Okay, what is the first sign or what is the earliest sign of cellular injury is the cell swelling. But remember, exceptions are equally important for our exams. And whenever you read exceptions, you read them carefully as a future question. So here also you can see all type of cell injuries, cell swelling is the first sign. Except, what is that exception? So as I said, first sign of cell injury in all kind of cell injury except for which condition? So that is another important question. Except for apoptosis. Except for apoptosis, right? Because in apoptosis you will find cell shrinkage, and that is another important question which examiner had asked in both All India and AIMS exam. Cell shrinkage will be seen in apoptosis. Remember this point, cell shrinkage will be seen in apoptosis. That is the question in AIMS as well as All India both exam. So cellular swelling is the first sign of cell injury, but exception is apoptosis where you will find cell shrinkage. Now it is very important to understand that we should keep revising subjects, right? Keep revising, keep reading the subject so that we can correlate many things together, or we can correlate one topic to another topic or one subject to another subject. So here I am going to give you a perfect example. When you revise and you correlate, you understand certain meaning. For example, how we are going to correlate cell swelling to the ballooning degeneration of the hepatocytes. Question asked in All India exam was, ballooning degeneration of hepatocyte is a feature of acute hepatitis or chronic hepatitis? Ballooning degeneration, acute or chronic? So what is ballooning degeneration? It's a cell swelling. It's very simple question. What is ballooning degeneration? Take this example. Take this example which examiner had asked in All India exam. Ballooning degeneration of hepatocyte. Ballooning degeneration of hepatocytes. So that was the question in All India exam, right? One of the often asked question in exam, and we tend to mug it up. But now we can understand. Cell swelling is the ballooning. Hepatopathologists, they are calling them as a ballooning. Cell swelling is the ballooning degeneration of the hepatocyte, and cell swelling is the first sign. First sign means acute or chronic. First sign means acute or chronic. It's a acute. So ballooning degeneration is the first sign. So this will be feature of acute hepatitis. So this will be the feature of acute hepatitis. It is seen in acute condition. It is first sign acute. So ballooning degeneration is the first sign acute hepatitis finding. That is how we can correlate, right? So when water is entering inside the cell, because of the sodium entry, what will happen to the cell? Cell size has been increased. So again, I would like to show you. See this is the cell, this is the nucleus. As I said, water is coming inside the cell. So this water will be getting accumulated inside the cell. And because of this accumulation of water, cellular size is increased. So this water, intracellular water accumulation is called as vacuolar. This is vacuole. So this is called as vacuolar degeneration. Vacuolar degeneration, or it is also called as hydropic changes. Hydropic degeneration. So vacuolar degeneration, hydropic degeneration, these are the finding of reversible injury. So right now we are talking about reversible injury. Earliest sign is cell swelling. There may be hydropic change or there may be a vacuolar degeneration because of intracellular water accumulation. Intracellular water accumulation, where you are seeing hydropic changes, sometimes this is also known as, remember, sometimes this is also known as cloudy swelling. This was the All India and DNB question. Cloudy swelling. Remember this wordings which examiner plays in our exam. Cloudy swelling, which of the following is having intracellular accumulation? Question is cloudy swelling, which of the following intracellular accumulation will be seen? Glycogen, protein, fat or water? So what is this? Water. So always remember cloudy swelling. This is intracellular water accumulation. And cloudy swelling example is the acute tubular necrosis of the kidney. Right? So in acute tubular necrosis of the kidney, tubular epithelial cells will be showing cloudy swelling. Right? As you can see in this particular diagram, if you are looking at this image which I am showing you here, in this image we can notice, as I have told you, always remember for image based question, rule of 5, all 4 corners and the center, rule of 5. So these 5 area we have to look for, then you observe, then you compare, right? So 5 areas when I am looking, and when I am comparing this area to the surrounding area like this, where I am seeing there is a normal cell, nuclei are visible, whereas when I am observing this kind of cell, you can see the cell size has been increased, right? They are increased, and if you look at them, they are not eosinophilic. They are having something frothy or foamy appearance because there is a water inside. Because of entry of the water, they are called as hydropic change. And this is the cloudy swelling or hydropic change or cellular swelling, right? So this picture is perfect demonstration of the hydropic change. So what we are seeing here, these are the water inside the cell. Because of water inside the cell, there is a cellular swelling, right? And this cellular swelling is also called as cloudy swelling or hydropic degeneration or vacuolar degeneration, right? So we have seen how this reversible injury goes on. Same thing when this channel will be defective at the level of organelle, right? At the level of organelle, then you will notice certain changes. So what are the organelle changes? So now I am going to show you what are the organelle changes. So what are the changes you will notice in organelle? First, I would like to tell you, whenever we are seeing any organellar changes, we require to see electron microscope. Whenever examiner will write electron microscope, he may write ultra structurally. So in our textbook also you might be reading ultra structurally, which of the following is characteristic feature. So whenever examiner says ultra structurally, we must keep this in mind. Examiner is probably talking about electron microscope, and organelle will be seen by electron microscope. So number 1, here on electron microscopy or ultrastructurally, when I will discuss number 1 is about endoplasmic reticulum. Suppose this is the endoplasmic reticulum, right? So just I am making a schematic diagram for understanding it. Suppose I am writing this is the endoplasmic reticulum, right? There are two types of endoplasmic reticulum, smooth and rough. Rough endoplasmic reticulum, they have ribosomes on their surfaces. They have ribosomes on their surfaces, right? So these are ribosomes, right? Because of the ATP decrease, sodium potassium pump was failed, and because of the sodium potassium pump failure, what will happen? Here also you will see that water will enter, right? So if water enters inside the endoplasmic reticulum, so what will happen to the size of endoplasmic reticulum? Same like cell. They will be also having swelling. So there will be endoplasmic reticulum swelling, right? So here I would like to show you endoplasmic reticulum will be also having swelling. So there will be endoplasmic reticulum swelling. So endoplasmic reticulum swelling will be there. Endoplasmic reticular swelling. So that was also one of the important question in All India exam. Endoplasmic reticulum swelling is a feature of reversible injury. So if there is a swelling of endoplasmic reticulum, then what will be the fate of the ribosomes present on their surface? Because of the swelling, ribosomes will detach and they will fall down into the cytoplasm, right? So what will be the next change? Ribosomal detachment. So there will be ribosomes, and this ribosomes will be having ribosomal detachment from the surface of the endoplasmic reticulum. So ribosomal detachment, this is another important question which examiner had asked in All India exam. So endoplasmic reticular swelling and ribosomal detachment will be seen on electron microscopic examination or on ultrastructural examination of reversible injury, right? So reversible injury, what we are seeing, endoplasmic reticulum swelling, endoplasmic reticulum swelling and ribosomal detachment, right, on electron microscopy. Now my question is, will you find mitochondrial damage in reversible injury? Mitochondrial damage in reversible injury, will you find? Yes or no? Answer is yes, we will see. So here I want to tell you one important thing. When you are going to observe this second organelle which is called mitochondria. So what will happen to the mitochondria, right? So that is the point I wanted to discuss, right? If you look at the normal mitochondria on electron microscopy, right? If you look at the normal mitochondria on electron microscopy, you will be seeing a cristae which will be spanning through the mitochondria. So these are called cristae, mitochondrial cristae, right? So this is the normal mitochondria. So what I am showing you here, this is the normal mitochondria. But during the cell injury, when there is a cell injury, means I am talking about reversible injury. I am talking about reversible cell injury. In reversible cell injury, what will happen to the mitochondria? Mitochondria will be swollen up and cristae will be lost. See what I am showing you here, mitochondria is swollen up and there is no cristae. So what I am showing you, mitochondrial swelling. So remember, in mitochondria, what we will see, mitochondrial swelling. Mitochondrial swelling will be present, mitochondrial cristae will be lost, and inside the mitochondria there will be a deposit of calcium plus mitochondrial membrane. So some amount of the membrane which has been damaged, membrane plus calcium. So this membrane we know that phospholipid membrane is made up of phospholipid. So this phospholipid and calcium, right, membrane is made up of phospholipid. So phospholipid and calcium, they will form a small amorphous density. What I am writing, a small amorphous density. That is very important catch point. When examiner has written this point in All India exam, a small amorphous densities are seen inside the mitochondria is a feature of very important. That is why, student, I say keep your focus on the language of the question. Do not get biased in your exam time. Examiner is not talking about large flocculent. Examiner is talking about small amorphous densities, and small amorphous densities are feature of reversible injury of the mitochondria. So my question, you remember just now what I had asked you, कि mitochondria, will it be damaged in reversible injury? And I said, yes, it will be damaged. What will be the finding? Earliest finding will be mitochondrial swelling. And you will notice there is a small amorphous densities within the mitochondria. So these are very important things which you will observe in a reversible injury of the mitochondria. And remember, all these changes will be visible on electron microscopy. All these changes will be seen on electron microscopy, as I am going to show you in this picture, right? So look at this diagram where I am showing you electron microscopy of the mitochondria. In this electron microscopy of the mitochondria, as I have told you, the mitochondria will be elongated and they will be having cristae. But in this case, when you are seeing all these mitochondria, they are not elongated. They are round because they had been damaged, and because of the entry of water, they had been swollen up. So all these are swelling of the mitochondria. So these are swelling of the mitochondria, which I have told you. So now you can see this mitochondria is swollen. They are not elongated. Normal mitochondria will be elongated, but these are swollen up, right? So these are swollen up, and that is why they are round. And when you will observe these two mitochondria, see this and this also. So these three mitochondria, I am marking it 1, 2, 3. All three mitochondria, you can notice there are dark color deposit. There are dark color deposit on electron microscopy. When we see this kind of dark deposit, these are called as electron dense deposit. So what I am showing you here, these are called as electron dense deposit. So electron dense deposits are, these are, if you see, they are having no morphology. That is why they are called as amorphous. That is why they are called as amorphous. There is no morphology. Amorphous. So these are amorphous electron dense deposit. How are these amorphous deposit? Are they big or small? They are small. So these electron dense deposits are small amorphous deposits. So these are small amorphous deposits within the mitochondria. So whenever you see a small word in your exam, always remember it is a feature of reversible injury. So this electron microscopy is showing reversible injury where we are noticing small amorphous densities within the mitochondria, and mitochondrial swelling is there where we cannot observe well-defined cristae which is traversing the mitochondria matrix, right? So that is very important. Swelling and small amorphous densities, feature of reversible mitochondria. When you will observe them? On electron microscopy. So remember what we are seeing? We are looking at electron microscopy of reversible injury of mitochondria, showing swelling and small amorphous densities, right? So these are findings which you will see in organelle, right? Now we will see one more electron microscopic finding, and that electron microscopic finding is another characteristic finding which we should understand, which we will find in reversible injury and we will see in irreversible injury also. So that point, before I discuss, I want to tell you another concept, and that concept is, what is the most important factor for cell injury? What is the most important factor for cell injury? So I am not talking about ischemia and hypoxia. I am talking in terms of element, ion. Which ion is most important factor, calcium or sodium? So answer is, most important factor for cell injury is calcium. Calcium. Calcium is more important. Why calcium is more important? I will discuss, right? Beforehand, I want to ask you another question. Which calcium? Which calcium? Which is present in serum or which is present inside the cytoplasm of the cell? So always remember, it is cytosolic calcium which is present inside the cell cytoplasm. So it is directly proportional to the cytosolic calcium level. So cytosolic calcium is the most important factor for cell injury, right? Why this is important? Now we will understand. Suppose I am showing you this is this cell right? And as I have told you, when there is a ATP depletion, sodium will enter inside the cell, and along with the sodium, water will enter inside the cell. So this point, we have to understand one more important thing. Along with the sodium and water, there will be calcium entry also. So there will be calcium influx also inside the cell. So this cytosolic calcium will decide the nature of cell injury. When this cytosolic calcium is having mild increase, this will cause reversible injury, right? This will be causing reversible injury. When this cytosolic calcium level will be very high, right? Then this will be causing irreversible damage, right? So that is the important thing we have to understand. Okay, that is why I said when we are talking about cytosolic calcium level, as we are seeing in this case, right? So now we are seeing a cytosolic calcium level. Cytosolic calcium level. When they are mildly increased, they will cause reversible injury. When they are severely increased, they will induce irreversible damage to the cell. How this calcium is associated with all these cellular injury? So that is another important point we have to understand, right? Now we are talking about reversible injury, so we will focus on reversible injury. Whenever cytosolic calcium level is having mild increase, this will activate phospholipase enzyme. Right? So this will activate phospholipase enzyme. So as I said, cytosolic calcium will activate phospholipase enzyme, and we all know that phospholipase will damage the phospholipid present on cell membrane. So phospholipid will be damaged, which is present on cell membrane, right? So phospholipid of cell membrane will be damaged by this activated phospholipase. So when this phospholipid will be damaged, what you will notice inside the cell? Because of the phospholipid is there. So what I said, because of the phospholipid and calcium inside the cytoplasm. So this phospholipid and calcium, they will be forming a characteristic walled lamellated appearance of the phospholipid and calcium. So this will be characteristic walled appearance. So what I'm showing you, these are whorl-like appearance. So this whorl-like appearance looks like a cut section of the myelin sheath. That is why this whorl-like appearance is also called as myelin figure. So that is important for exam point of view also. So that is why it is called as myelin figures, right? So these are myelin figures which will be seen, right? So question asked in All India exam was, the myelin figure is derived from. What is the origin of myelin figure? Why I had explained the concept like this? Calcium will be there, mild increase, phospholipase will be activated. They will be causing damage of the cell membrane. Phospholipid will be released. Phospholipid will combine with the calcium, and this will form the myelin figure. So what is myelin figure origin? Myelin figure is derived from cell membrane. That was the All India question. So myelin figure is derived from cell membrane. So that was the question in All India exam. Myelin figure is derived from cell membrane or organelle membrane. So that was the question. Second question is, what is myelin figure is made up of? So myelin figure is made up of phospholipid and calcium. Another important All India question. They are made up of phospholipid and calcium. So this is the another important question which examiner had asked. Myelin figure is made up of phospholipid and calcium. Where you will see myelin figure? Reversible injury or irreversible injury? So what will be answer for this particular question? That was another All India question. So just remember this point. This myelin figure is seen in both reversible and irreversible injuries. So both reversible and irreversible injury will be having myelin figure, both. But if we have to choose a single best answer, your answer must be irreversible injury. Why irreversible injury should be better answer than reversible injury? Because myelin figure synthesis starts in reversible injury, and it will be maximum in irreversible injury. So that is why I would like to tell you, if examiner asks you a simple question, myelin figure will be seen in reversible, irreversible, both. Answer should be both. But when examiner is asking you to choose the single best option, your answer should be irreversible injury, because they will be having maximum myelin figure, right? And myelin figure will be visualized by which microscope? Light microscopy or electron microscopy? So they are seen in cytoplasm, and this will be seen on electron microscopy. So concentric whorl-like appearance. So concentric whorl-like appearance of myelin figure will be visible on electron microscopy, as you can see in this particular diagram. This is the electron microscopy. You can see this is the electron microscopy. You can notice these structure. Yes, this one, this one, this one, and this one. So these are the four marked area, and certain extent this one also. So these are the four marked area where you can see there is a concentric lamellated whorl-like appearance. Can you see concentric lamellated whorl-like appearance, which is made up of phospholipid and calcium, which is derived from the membrane of an organelle. So these are important things we have to understand. Okay, right now we are seeing electron microscopy. Right now we are seeing electron microscopy showing myelin figure made up of phospholipid and calcium. So that is the important point we have to keep in mind, right? Myelin figures, ultrastructurally or electron microscopy, they will be showing concentric whorl-like appearance, right? Now we will see another interesting point regarding reversible injury. In reversible injury, when examiner will be asking you this question, ki nucleus, what will happen to the nucleus in reversible injury? Will they have any damage or no damage? That is very important and very conceptual point we have to understand, right? If you remember, when I started cell injury and I said ki cell injury is because of ischemia hypoxia due to free radical, and we understood ki free radical, when they are produced, they will damage everywhere, even the nucleus. You remember nucleus, they will cause DNA damage, chromatin damage. Recall that thing. Nuclear damage, chromatin damage. So yes, if examiner says reversible injury, nucleus will be damaged, answer will be yes, there will be nuclear damage. So just I am writing in a simple word, nuclear damage will be present in the reversible injury. What nuclear damage you will see? So this can be a future question which I'm going to discuss now, right? What will be the nuclear damage? So before we understand nuclear damage, I would give you a brief introduction about the cell. Cell is having eosinophilic cytoplasm. Cell will be having eosinophilic cytoplasm and blue color basophilic nucleus. See what I'm saying? Eosinophilic means pink or red in color. So pink or red cytoplasm, eosinophilic cytoplasm, right? And when you will see the nucleus, nucleus will be basophilic. Basophilic. Basophilic means blue. Basophilia, B for basophilia, B for blue. So cytoplasm is blue, and inside the cytoplasm you will notice that chromatin is arranged in granular and fibrillar pattern. This is called granular and fibrillar. So why they are basophilic? Basophilia is because of granular and fibrillar chromatin. So granular or fibrillar chromatin is present in nucleus, right? So granular or fibrillar chromatin is there inside the nucleus. So this is the normal. So this is the normal cell, normal nucleus. So what I said, this is the normal. So always remember what I am talking about a normal cell. In a normal cell, eosinophilic cytoplasm will be there, basophilic nucleus will be there, basophilia will be having granular and fibrillar arrangement of the nuclear chromatin. But during reversible injury, when free radicals are produced and they are causing damage to the chromatin and DNA, this granularity and fibrillarity will be lost, right? So there will be loss of granularity and fibrillarity. So in reversible injury in nucleus, what changes you will see? So that will be written as a disaggregation of, right? So you can see chromatin was aggregated here in the form of granular and fibrillar pattern. So there is a disaggregation of granular and fibrillar nuclear chromatin. Granular and fibrillar nuclear chromatin. So disaggregation of granular and fibrillar nuclear chromatin. This can be a future all India question. So just Students, keep this in mind. Whenever you are studying any topic, it's not only necessary to solve the previous year question. We should also understand what can be the future question, tricky question, twisted question, which examiner may ask in future exam. And this is a beautiful question, because we often understand that nucleus is getting damaged only in irreversible injury. But now I am demonstrating you how nucleus will be damaged in reversible injury with the support of concept. Concept is free radical can damage nucleus, which was produced because of ischemia or hypoxia, and because of the free radical, they will cause damage of the chromatin, and this chromatin will be damaged. They will be in the form of disaggregation of granular and fibrillar nuclear chromatin. So can be a future potential MCQ in exam. So this is reversible injury, right? So till now, that lethal stimuli is transient. If you remove the stimuli, still cell can revert back to the normal state with some loss of morphology and physiology and their functions, right? With some loss. It's not cellular adaptation. That's what I'm saying. With some loss of physiology or morphology of the cell. But when this stimuli is persistent, when lethal stimuli is persistent, cell will undergo to irreversible injury. So now we are going to discuss about irreversible injury. So as I said, irreversible injury is because of persistent lethal stimuli. So that is important. Persistent lethal stimuli. What will happen because of this persistent lethal stimuli? If there is a persistent lethal stimuli, how this will cause irreversible injury? Because of the persistent lethal stimuli, there will be continuous influx of the sodium inside the cell. So there will be persistent increase in cytosolic calcium. So now we can see cytosolic calcium level will be very high. Because of this increased cytosolic calcium, now you can see that in mild injury, in reversible injury, there was mild increase. So that is why only phospholipase was activated. But when there is a very high level of the cytosolic calcium, this will activate 3 groups of enzyme. Remember, 3 groups of enzyme. So this cytosolic calcium will activate 3 group of enzymes, which we are going to discuss in this irreversible injury. So what are these 3 group of enzymes? Number one, already we have discussed about this phospholipase, which was activated in reversible injury also. So phospholipase will be activated. Second enzyme is proteases. So this is extra. Proteases will be activated. And third group of enzyme is endonucleases. So these are 3 group of enzymes which will be activated by increased cytosolic calcium in irreversible injury, right? So now we will see what will happen. When phospholipase is activated. Already we have discussed, upon activation of the phospholipase, what they are going to do? Phospholipase will cause damage of the cell membrane, right? So there will be cell membrane damage. So because of the cell membrane damage, what you are going to expect? There will be increased amount of myelin figure. So myelin figure will be increased in irreversible damage, as I have discussed there. The myelin figure will be maximum in irreversible injury. As I have discussed already, myelin figure will be maximum in irreversible injury. And second important thing is about mitochondria. What are the changes you will see in the mitochondria in irreversible injury? Swelling will be there, no doubt. Crusty damage will be there. But what is characteristic thing which examiner asked in exam on electron microscopy of the mitochondria on irreversible injury? You will notice they will be having large flocculent amorphous densities. Large flocculent amorphous. Amorphous means no morphology. Amorphous. Morphous means morphology. Amorphous means no morphology. So that morphology will be indistinct. That is why amorphous, large flocculent amorphous densities in mitochondria. Large flocculent amorphous densities within the mitochondria, and that is the one of the most frequently asked question in AIMS and All India exam. So that is what I wanted to tell you that time. Language is very important. When examiner is talking about large flocculent amorphous densities, large word. Remember the word is large. Large flocculent amorphous densities, irreversible injury. A small flocculent is reversible, right? A small flocculent, reversible. Large flocculent is irreversible injury of the mitochondria. This point we have to keep in mind, right? And here I would like to show you how you will find the large flocculent amorphous densities in the mitochondria. So I am just showing you this diagram is again another electron microscopy. So what I am showing you here, electron microscopy of the mitochondria, right? I am showing you electron microscopy of the mitochondria, and I would like to bring your attention to these marked area which I am going to mark here. This one, this is the mitochondria. We can see this mitochondria is full of electron dense. You remember what I said? Whenever you are seeing the dark substances inside the mitochondria on electron microscopy, they will be considered as electron dense deposit. Electron dense deposit is small or large. If you compare this, the previous picture, see this, small amorphous density is was reversible injury. Now what I am showing you here, I am showing you a large amorphous densities. You can see large amorphous densities are here also. So large amorphous densities. So what I am showing you, large amorphous densities, large amorphous densities. So large amorphous densities are feature of irreversible injury. So this is the ultrastructural or electron microscopic view of the mitochondria showing large amorphous densities, which is a feature of irreversible injury, right? So coming back to the calcium level. So see what I have said, because of the increased cytosolic calcium, phospholipases, proteases, endonucleases has been activated. Phospholipase is forming myelin figure and large amorphous densities within the mitochondria. Both will be seen on electron microscopy. Proteases, what they are going to do? What they are going to do? Proteases, as the name itself is telling, they will cause damage of the cytoskeletal proteins. Cytoskeletal proteins damage, right? So these proteases will be damaging the cytoskeletal protein, and because of the cytoskeletal protein damage, because of the cytoskeletal protein, cells are smooth and round, right? But because of the damage of the cytoskeletal protein, what will happen? There will be loss of cell architecture. So there will be loss of cell architecture. So cellular architecture will be lost because of the cytoskeletal protein damage caused by proteases. This is the second important thing. And we all know that once the cellular architecture is lost, that is the point of irreversibility, right? That is the point of irreversibility, means that membrane has been damaged, and this is the irreversible damage. Membrane is the most important factor for distinguishing between reversible and irreversible. Membrane damage will be more in case of irreversible damage, whereas less in case of reversible damage. And this is the most important factor. Look at the endonucleases. What will be the role of this enzyme? If you look at the name itself is telling endonucleases. So endonucleases, they are going to damage which area of the cell? Nucleus. So they will be causing nuclear damage. In nucleus, what is present which they will be causing damage? In nucleus, what is present? Chromatin. And what is chromatin made up of? DNA. So they are going to cause nuclear DNA damage. Nuclear DNA damage, which is present in chromatin. So this will be causing nuclear DNA damage in the form of chromatin or DNA damage. So what are the DNA damage or what are the chromatin damage in the nucleus performed by endonucleases, right? So that is also one conceptual thing. They will be causing sequential damage of the nuclei. Sequential. In a sequence, they will cause the damage, right? So now we will see what is that sequence. That was also one of the older All India question in NEET exam only. So suppose I am showing you this is the cell, and this is the nucleus. We all know that chromatin is granular and fibrillar. They are like this inside the cell, granular and fibrillar chromatin. This is the normal cell, right? As I said, whenever endonuclease will be released because of the cytosolic calcium, they will cause sequential damage, and there are three types of damages in a nuclei. What are those three kind of damages? In a sequence I am going to write. Number one is called as pycnosis. Number one is called as pycnosis. So this sequence they will follow. When endonuclease is slightly raised, pycnosis will happen. After pycnosis, what will happen? Second thing will be karyorexis. Karyorexis. So after that, karyorexis will happen. So pycnosis, karyorexis, and third one is karyolysis. Karyolysis. So these are the sequential damages which was asked in All India exam 2015. Question was, what is the sequence of nuclear damage caused by endonuclease? So whenever endonuclease level will be increased, pycnosis first, karyolysis followed by, and in the end, pycnosis, karyorexis, and then karyolysis. This is the sequence, right? Now we will see the meaning of these words and we will try to understand the concept. What is pycnosis? Question is, what is pycnosis? So whenever there is a high level of endonuclease inside the cell, as I have told you, this is the cell and this is the nucleus. So what happens in pycnosis? Because of endonuclease, DNA is damaged, so chromatin will be forming clumps, being granular. See, it was granular here, but because of the damage, now they will be forming irregular clumps, and this clumping of chromatin will be there, right? So there will be clumping of chromatin. Clumping of chromatin or condensation of chromatin, otherwise also called as condensation of the chromatin. Clumping of chromatin, condensation of chromatin can be seen in reversible injury also. What I said, clumping or condensation will be seen in reversible injury also. So now the question comes to our mind, what is pycnosis? Here also we are seeing clumping or condensation of the chromatin. Then how we are going to differentiate? How we are going to differentiate pycnosis from the clumping of the chromatin of the reversible injury? What is pycnosis? What is the concept of pycnosis? We have to understand. Pycnosis is not only clumping of the chromatin. Remember, pycnosis is not only clumping of the chromatin. It is clumping of the chromatin plus shrinkage of the nuclei. So nucleus shrinking. So nucleus shrinking along with clumping of chromatin is called as pycnosis. So that is the point we have to keep in mind. Nuclear shrinkage plus clumping of chromatin is called as pycnosis. So for showing the nucleus shrinkage, I am showing you by this, right? So this is the diagram where I want to show the nucleus has been shrunk. So shrinking of nucleus will be there. Shrinking of nuclei along with clumping of chromatin is called as pycnosis. So that is the concept of pycnosis. We must remember, it is not only condensation of the nuclear chromatin. Along with the condensation of the nuclear chromatin, there must be nuclear shrinkage. That is called pycnosis, right? So after that, when endonuclease level will be more high, they will induce karyorexis. What do you mean by karyorexis? It's a Greek word. So see, what is the karyorexis? Karyon. Karyon means nucleus, right? Karyon means nucleus, and rexis means fragmentation. So nuclear fragmentation is called as rexis. Nuclear fragmentation is called as rexis. So when you will see a cell, inside the cell there is a nucleus. Because of endonuclease level is high, so nucleus will be fragmented into several small pieces, right? So we can see that nucleus is fragmented into several small pieces. This is called fragmentation of the nuclei, right? So this fragmentation of nuclei is called as karyorexis, right? So we all know that life of a cell is a nucleus which is having DNA, right? And now that nucleus has been broken into small pieces, so life is gone. So they are of no use. So what will be the next step? Whatever nuclear chromatin is present inside this broken nuclear fragments, they will be lysed by endonucleases. So again, when more higher level of endonuclease will come, then they will cause chromatin lysis. And after chromatin lysis, they all will be thrown outside through the cell membrane pores. So when chromatin lysis and they will be thrown out of the cell membrane pore, that will be called as karyolysis. So what is karyolysis? What is karyolysis? Karyolysis is the chromatin lysis and dissolution. Chromatin lysis and dissolution. Chromatin lysis and dissolution. So chromatin will be lysed and dissolved. So again I am making one cell. So just here observe this cell, and just for the sake of understanding I am just making some of the blue fragments because majority of the chromatin has been dissolved and they had been thrown outside, right? So when chromatin has been dissolved and thrown outside through the membrane pores, so you tell me what will be the appearance of this cell? More eosinophilic or more basophilic? Tell me. More eosinophilic or more basophilic? All the basophilic material chromatin has been removed through the membrane pores. So what is the resultant effect? More eosinophilia will be there, right? More eosinophilia, or you can say otherwise, there is a less basophilia of the cell because chromatin has been lost. So because of this chromatin lysis and dissolution, what we are observing, there is a decreased basophilia. There is a decreased basophilia of the cell. So that is very important. This is the question in All India exam. What do you mean by karyolysis? See, the question was, what do you mean by karyolysis? Many students, they understand that lysis means fragmentation of the nucleus. No, here it is not that. Fragmentation of nuclei is the karyorexis, rexis. Lysis is the chromatin lysis and dissolution, and because of that, what you will observe, there will be decreased basophilia, and that was the right answer. Decreased basophilia is known as karyolysis. Why decreased basophilia? Because chromatin was dissolved and thrown away from the cytoplasm. So these are the three sequential changes in any irreversible injured nuclei. So that is what I wanted to tell. Reversible injury, nucleus will be showing condensation, or you can say condensation. Remember, nucleus will be having condensation, but that is not pycnosis. What is pycnosis? Always remember this point. Pycnosis is the clumping of the chromatin and nuclear shrinkage, right? But only clumping of the chromatin is a feature of reversible injury of the cell. In irreversible injury, there is a nuclear shrinkage. So pycnosis, karyorexis means nucleus will be fragmented into pieces, and karyolysis means chromatin will be dissolved and they will be thrown out from the cell membrane pores. And that is how, when they are thrown out of the cell membrane pores, basophilia is the decreased because nucleus has been decreased. So that is why in necrosis, when we will discuss, or in dead cell when we will see, we will always say that there is a more eosinophilia because nucleus has been thrown away. They have been dissolved by endonuclease level. So this is the irreversible injury. Three important nuclear changes: pycnosis, karyorexis, karyolysis in a sequence. Next topic which we are going to discuss will be sequence or sequelae of the irreversible injury. What will be the sequelae of irreversible injury? So I will just tell you in a brief that after irreversible damage, after irreversible injury, what will happen? There will be cell death. So after irreversible injury, see what we have seen just now, we have seen irreversible injury. After irreversible injury, what will happen? Cell death. And after cell death, there are certain morphological changes. There are certain morphological changes, right? So what are the morphological changes we are going to discuss here? There are four morphological changes we are going to discuss. One is necrosis, and second is apoptosis, and two more new entities which we have to understand here: necrosis, apoptosis, and necroptosis and pyroptosis. So these are the four important morphological changes we are going to see. So this is the sequelae. You remember how we started? We started with the altered physiological stimuli causing cellular adaptation. When it was lethal stimuli causing cell injury, transient leading to reversible, persistent causing irreversible injury, and after irreversible injury there will be cell death. After cell death, Morphological changes. So next topic we are going to discuss is morphological changes like necrosis, apoptosis, necroptosis and pyroptosis. So these are the four important morphological changes which we are going to discuss now, right? So these are the four morphological changes after cell death which we are going to discuss